So there is another way to express change in momentum, and it's really, really useful, tons of applications. So change in momentum is mass times change in velocity. So I'm just going to algebraically manipulate that, rearrange it, and we're going to get something new out of it. So because I can, I'm going to divide both sides by time. Okay?
Where did time come from?
It's just the time during, this is a collision problem usually,
Okay.
so it's the time for the collision. And I remember you can do, as long as you do the same thing to both sides of the equation algebraically, it's fine, right? So, but that's a good question. Another way to say change in velocity over time is acceleration, right? So I'm just going to substitute acceleration and carry that down, so change in momentum over time equals ma. And then, because I can, I'm going to rearrange some variables again, so I'm going to multiply both sides by time. So that cancels. So now I'm back to change in momentum. And what's another way to state ma? Force, good. Yes. So now we have change in momentum, mass times delta V, can also be expressed using force and time. So m delta V, that's change in momentum. Ft has a special name, and it's called impulse. Okay, impulse. F is the force on impact. So these are collisions that we're talking about. The force on impact. T is the contact time. So it's impact force multiplied by contact time. And athletes use this all the time. We use this equation for safety devices, okay, like how to make cars safer for collisions, especially now that we've got much, much smaller cars. So if you think about it, let's say that you're driving one of our new little smart cars that are so cute and so great with gas mileage and, oh, dangerous. I mean, there'd be great, a rolling coffin. They would be great if everybody was driving them, and it is why it's safer to drive that type of a car in Europe, because there are a lot more people that drive smaller cars. But getting a collision with a smart car versus, I don't know, like a Suburban, right? Or a Hummer. Yeah, that's a practical vehicle. And you know, I love it when I see people driving Hummers around town, because you need that. You never know when, there could be like, I don't know. Sure, some IEDs right around, like on Niles Avenue or something. So, yeah, you need that.
I saw a video about smart cars, and they're like, they had known people who were saying that the car was unsafe.
Right.
And so they did a crash test and put it on YouTube, and they showed that it doesn't collapse, it just bounces off. So you don't get crunched, you just get wicked whiplash.
Right. Well, and they do design newer cars and not just smart cars for things like with crumple zones and side airbags, and all of those are to increase contact time. So when you have when you're driving a big old battleship, you don't really need to worry about crumple zones, because you're just carrying all of that mass into the collision. Yes.
And then I'm curious, you know how magnets, if you put after north and north together, they repel each other?
Uh-huh.
What if you could do that with cars and different materials, would bounce away from each other?
That would be pretty sweet.
Bumper cars, and then you just keep going around those. If you hit a tree, which is a magnetized, then you're dead.
Well, no, but I'm saying not make it so unmagnetized where you can do it with different materials. So I could go ahead and get a tree, the car would deflect from the tree.
Yeah, there's another theory. Yeah, that would be a little complicated, but yes, you could do that in theory. There's another theory that says that the best way to make vehicles safest is to take out the human element.
Yeah.
Don't let people drive them.
Yeah.
And how would you do that?
Robot.
You could have robots. Google, do you know that Google, Google has made
It's on top here.
a robotic car that
I know, but
is
robots
able to
are
respond.
still made by humans, so
Well, yes.
robots still have human error, which,
The other thing that you could do is make sure that you have just a system like the infrastructure. So you were talking about magnets, right? Make it so that it's like a maglev type device, and so you would always know where every car was on the road. And there would be no you just get in your car, you punch in your destination, and then all cars would work together. All speeds would be adjusted. It would be less fun, yeah.
No.
I've got a fun solution.
Uh-oh, we have a fun solution. What is it, Thomas?
They got it right in the 50s, flying cars. Not
Well,
only is it safe, but it's fun.
There are flying cars. There are personal flying machines. They're like kind of like helicopters, and you can actually park them in your garage. They're small enough.
as long as it's
Wings fold up.
By 2000, we'd all have private helicopters for ourselves.
Didn't kind of work out. Yeah, there's some cost limitations.
The world wouldn't exist after 2000, so.
Yeah, exactly.
Sometimes predictions don't hold true. All right, let's talk about sports for a minute here.
Get away from cars.
Yeah, we do. Impulse is used a lot by athletes. Think about sports wherein collisions occur, or like a lot of ball sports, so tennis, golf, soccer, even basketball, volleyball, anything where you're trying to move a ball, you're hitting a ball, football, anything where there's a ball that's moving. Athletes use this idea of impulse. So impulse is Ft, and that equals m delta v. Okay? So the goal, this is the mass of the ball, and the goal is to change the velocity as much as possible. So make the ball go really fast. You can do that two ways. You can do that by hitting it really hard, increase the force, right? So hit the ball hard, and that will be translate, because you're not going to make the ball more or less massive, right? The ball is the ball. But that would make this number bigger. What would another way be to make this number bigger on this side of the equation? Go, Stephen, go. Yes. Be in contact with the ball for a longer period of time. So anybody that participates in any of those ball sports, how do you do that? Follow through. Follow through. Do I have any tennis players in the room? Okay. So, a ground stroke versus a volley, right? Hannah knows what I'm talking about. Anybody else? Yeah, a ground stroke is like from the baseline, from the back of the tennis court. It's a long, like full arm stroke, right? And you're trying to get it nice and low just over the net, maybe add a little spin, right? Get it into the back court, woo, crazy bounce, right? But you want it to go fast. So you're going to hit with follow through. If you're hitting a volley shot, that's a quick punch right up at the net, right? Even if you took PE in 9th grade, you had a little tennis unit. You probably did that, right? Okay. Or if you ever took our summer rec tennis classes here, which is a pretty amazing program. They're like free or 20 or 30 bucks. Amazing that you can get that in the summer here. So, hit it hard and hit it with as much contact time as possible. Hannah, when you hit a ground stroke, are you in contact with the ball for the whole time that you're hitting it? For a good chunk of it, right? But not for the whole time. Any golfers in the room? All right, golfers. Same thing when you're hitting a driver for okay, I have no idea of anything about golf. Versus putting. In which case, in which example do you try to make contact with the ball for as long as possible? When you're driving or when you're putting?
It's kind of
Oh, dang it.
like baseball, like if you're full swing, you're going to be in contact with the ball longer if you're bunting.
Right, that's a really good example. Like hitting a line drive versus a bunt in baseball. The follow-through piece is to try to stay in contact with the ball as long as possible. If you can do both, if you can hit it hard and stay in contact with it, you get more change in velocity, right? Bigger change in velocity. Now, that's a different goal than when you try to reduce contact time. So reduction in contact time is done typically when you're trying to basically save your body. So anybody here ever like catch a baseball or a softball and lock out your elbow and it just stings like crazy, right? It hurts? Yeah. What's the way that you combat that when you catch a baseball or a softball that's coming? You do what? Use the web of your mitt. Yeah, pull back so you can move with the ball. Boxers do the same thing. If they're going to be hit and there's no way to get around it, you don't tense up. Yeah, you ride with the punch, right? You take it, but you relax. You ever hear about this every couple of years? Horrible car accident, drunk driver, right? Whole family is killed. Grandma, the babies, the whole family. The drunk walks away from the collision. That's right. He's all relaxed, right? So watch what happens. Sure. There's a moral here. No, you don't have to. You don't have to drive drunk. You just have to relax. Oh, head-on collision, 65 miles an hour. Relax. Remember what Ms. Nick said. Relax, relax, relax. Same thing. If you're skydiving, if you're skydiving and you're going to hit the ground anyways, don't tense up. No, relax. Why? What's the math?
A slipping flag, you're just...
Yeah, yeah. If you increase contact time by relaxing, right, this goes down. Why? Because you're stuck with this side of the equation. There's a different goal here, right? M delta V is you in your car. And then what happens is you get to mess with these two variables. So let's take the example of your driving. We'll not actually use drunk driving. We'll use your brakes go out, okay? You're driving down the highway. Your brakes go out. Oh, no, what do? A, relax. B,
You break.
yes, and they do this every driver's ed test, right? Oh my gosh, your brakes go, or you have to, swerve to not hit the little old lady that's in the road? Yeah. So what do you hit? Something soft. Big fluffy pile of marshmallows over here, or a 150-year-old oak tree on the other side? Why the big fluffy pile of marshmallows? It gradually slows down the car. That's correct. It increases the contact time. So the bigger your contact time, the smaller your impact force. This you're stuck with. What are some other safety mechanisms in cars that are designed to increase contact time? Airbags. What else? Seatbelts. What else? Crumple zones. That's a big one.
Tempered glass.
Tempered glass, yes. Takes a long time for tempered glass to shatter. Yeah. Anybody who takes my forensic science class, we actually demonstrate shattering tempered glass. Coolest thing. It does take a lot of force, but once it's so beautiful when it cracks. It is.
Why don't you take a nail and hit it?
It's way harder than that seems. Yeah. I used to use hammer and nails, and now I use actual, yeah, I did until someone stole it. But, because it was so cool, they couldn't help themselves. Anyways, there are actual devices, punches that are used by firefighters or emergency personnel to try to shatter windows to get people out of cars. Yeah.
Like, so you're saying when they do the little elbow thing in the movie, that helps it?
Not so much, right? That would end up with a broken elbow and a very fine, non-broken window. So.
Unless the car's really old, then you're gonna get it really cut up.
Yes. Go ahead, Stephen.
What about kicking through a windshield?
Kicking out a window, it'd probably be...
No, through, you're in front of the car,
yes.
The car's going towards you, and you jump and kick.
Like a ninja?
Yeah,
Oh, all right, roundhouse kick to the windshield. if you have the ability to do that, why wouldn't you just jump out the way? Just curious.